All right, welcome back. This is lesson 3 in our first unit dealing with parabolas and quadratics. So far, we've talked about how to identify what a function being a quadratic based on data, based on a table. And we knew that because the second differences were the same. And then we recognized the quadratic in a graph because we get this U-shaped object that's called a parabola. Well, today our focus is going to be on the different attributes of a parabola. In a line, you have different things like is the line increasing or decreasing? What is the y-intercept? What is the slope? What is the x-intercept? What's the domain and the range and all of that? With a parabola, it's all the same kind of things. It just goes a lot deeper because there's a lot of different parts to a parabola because it changes direction. Right? It goes from going down to going up or going up to going down. It's got what's called a vertex and different attributes. So with that said, our goal today, our objective, is to identify key features of a parabola, all the different parts of a parabola. So with that said, let's go ahead and get started. Now I'm going to minimize my screen here because we got a lot of information to take notes on. Make sure you're taking good notes. And by the way, just to emphasize some things, when you guys are taking notes, you should be in your notes writing the title and the objective, right? You should be writing these two things down. The objective should be rewritten as a question. So take this statement, I can identify key features of a parabola, and rewrite it as a question. But don't just flip the I can. Don't write it as can I identify key features of a parabola because that's going to be a yes or no question. The goal is to be able to write a question that you can answer, you can summarize at the end of this lesson with a few sentences. So maybe a good question for this would be, what are the key features of a parabola? Right? And then at the end, you can write a summary that explains what those key features are. But that's just a side note. Make sure you're taking good notes here. With that said, let's talk about those parts to a parabola. The first part is called the vertex, and we'll get to what that is. The next thing is called the axis of symmetry. And in fact, I would actually flip these. I would say the first thing is the axis of symmetry, and the second thing is the vertex, and you'll see why in a second. We have the idea of a maximum or a minimum, which means a high point or a low point. We have x-intercepts, just like we did on a line. And we have y-intercepts, just like we did, or y-intercept, just like we did on a line. So let's go ahead and take a look at a parabola here. We have a parabola that we would say opens up because you can see that it's going down and then up again. So it opens up. The opening of this parabola is on top. What is each of these things? Well, the vertex, the definition of the vertex is the point where the function changes direction, okay? The coordinate. Now remember, a coordinate is an x, y value. It's got to have an x component and a y component. So we can see that this parabola has a vertex, a corner, if you will, a place where it changes direction. You see, remember how we trace graphs? We always start on the left-hand side and move to the right. So we start at the left hand of the parabola and we move right. Well, as we move right, we can see that our function is moving downward. When we get to this point, as we continue to move right, we are going back up again. And so this point where it changes the direction is called the vertex. Well, what is that coordinate? That coordinate is 1, 4. So the vertex here is 1, 4, okay? The axis of symmetry is a line, a vertical line specifically, over which the parabola is symmetrical. What does that mean? Symmetry, symmetrical. Remember, symmetrical means that one side, if reflected like in a mirror, would match up with the other side. So how could I draw a line that will make one side of this match up with the other? Well, you can see that the axis of symmetry actually has to pass through the vertex every time in order to get symmetry, in order for one side of the parabola to match up with the other side of the parabola. So this dotted line here, it's a vertical line, is the axis of symmetry, okay? It's the line for which the things on the left are symmetrical with the things on the right. Okay, or in other words, the points on this side are the same distance away to the axis of symmetry as the points on this side. And for an example of that would be like this point right here. How far is it from the axis of symmetry? Well, it's 1 unit away from the axis of symmetry. If I move 1 unit on the other side, I end up at a point that is symmetrical with this point. So those are, this is the axis of symmetry. Another point would be right here. This is 2 points away from the axis of symmetry. This point is 2 points away from the axis of symmetry. This point up here is 3 points away, and this point over here is 3 points away. Anyways, how do we write the axis of symmetry? For the vertex, we wrote it as a coordinate. Remember, a coordinate is an x value and a y value, x comma y. Well, the axis of symmetry is a vertical line, and the equation of a vertical line is actually an x value. You can see that this line is lining up with the x value, x equals 1. Well, notice this, that the axis of symmetry, the x equals 1, is the x value of the vertex. These will always be the same. The axis of symmetry is the same numeric x value as the vertex's x value, okay? Now remember, when you're writing an axis of symmetry, you have to say x equals 1. You don't just say 1. It has to say x equals 1. Be careful with that. If it just says 1, you're not going to get full credit on any assignment. It has to say x equals 1. All right. The maximum or minimum, it's exactly what it sounds like. What's a maximum? A maximum is a high point. A minimum is a low point. In fact, it's the highest high point or the lowest low point. In this case, you can see in this parabola, remember parabolas, this is going to keep going upward in both directions. So these actually never stop going up, if you would. So do we have a high point or a low point? Well, in this case, we have a low point. And so this would be a minimum because it's the lowest point. And now what is the lowest value? The lowest value here is how far down the parabola goes. Well, it goes down to -4, and that is a y value. So the minimum is y equals -4. Well, guess what? You can see exactly what I was saying with the axis of symmetry. The axis of symmetry is the x value of the vertex. The minimum or the maximum is the y value of the vertex. So when you put the axis of symmetry together with the minimum or the maximum, you get the vertex. But again, for the minimum, you have to say y equals -4. The axis, or y equals something. The axis of symmetry, you have to say x equals something. Okay? So we have the vertex, the axis of symmetry, the maximum or the minimum. We have x-intercepts. Now remember, x-intercepts from Math 1 are the coordinates or the points where the function crosses the x-axis. Well, in this case, remember the x-axis is this horizontal line. Where does our parabola cross the x-axis? Well, it crosses here and it crosses here. Those are my two x-intercepts. Okay, it's where it crosses the x-axis. Now, x-intercepts are coordinates, just like the vertex is a coordinate. What is this coordinate? Well, this coordinate is -1, 0. And the other coordinate is 3, 0. Notice both of these have something in common. They both have a y value of 0 because we didn't go up or down to get to the x-intercept. The x-intercept is on the x-axis. So in x-intercepts, the y value will always be 0. And then the x value will be there, -1, 0 and 3, 0. Again, the way you write it is important. It has to be written as a coordinate. The y-intercept is exactly like the x-intercept. It's where the function crosses the y-axis. Well, where does this function cross the y-axis? This is the y-axis. It crosses right here at this point. So that is my y-intercept. Well, what is that coordinate? That coordinate is 0, -3 because I didn't go over side to side. I only went down. So it's 0 and then I went down 3. Notice the y-intercept is when x equals 0. The x-intercept is when y equals 0. So again, they're always going to be written as a coordinate. In the x-intercept, it'll be a number, 0. And then in the y-intercept, it'll be 0, some number. So those are the different pieces or the different parts of a parabola. We can go a lot more in depth with this. But let's go ahead and do a practice problem. I want you to identify all the components of the parabola below. So identify the vertex, identify the axis of symmetry, identify the maximum or the minimum, the x-intercepts, and the y-intercept. So go ahead and pause the video, answer it, and then come back and push play when you're ready. All right, so for this parabola, we see that the vertex is that point right there. That's where the parabola changes direction. That coordinate is -1, 4.5. That's kind of weird, but it's not exactly on 4 or 5, so we're just going to kind of guess that it's 4.5. For the axis of symmetry, it is the line for which the parabola is a reflection. That's the axis of symmetry. That equation is x equals -1. Again, x equals, okay? For the maximum or the minimum, you can see that we have a maximum. We have a high point here. So that is the maximum. The maximum is y equals 4.5. Notice again that the x value of the axis of symmetry and the y value of the maximum are the vertex. They're the values of the vertex, -1, 4.5. All right, the next thing is the x-intercepts. Well, the x-intercept, the parabola crosses the x-axis at -4, 0 and 2, 0. And then the last thing is the y-intercept. The y-intercept is where the parabola crosses the y-axis, so that's up here. That coordinate is 0, 4. All right, so hopefully you got all those right. Pretty easy concepts, I think. It's just vocabulary and understanding how to write the answers. Again, x-intercepts and y-intercepts, vertex are all written as coordinates. The axis of symmetry is written as an x equals equation, and then the maximum or minimum is written as a y equals equation. All right, with that said, let's go ahead and look at this terminology. Again, this is notes. Make sure you're taking it down. Direction. What is direction? Direction is the way that you are going. Now, we can go in our world, we can go in all types of directions. We can go left, we can go right, we can go forward, we can go backwards, we can go up, we can go down. But on a graph, the direction is only one of two things. It's either up or down, okay? Up or down. Remember, we always read a graph from left to right, but the direction is always up or down. So we would use these words. We would say increasing or decreasing. So when I say increasing, I mean up. When I say decreasing, I mean down, okay? So increasing, the actual definition is a function is increasing over any interval where the y value increases as the x value increases. In other words, let me go ahead and use my notebook here. Remember, I always read from left to right. So if I'm starting at this point, I don't ever want to go that way. I never want to go left. I always want to move in the right direction. So if I start going right, you can see that which way is my pen going? My pen is going up, right? So my function is increasing because as I move to the right, my function is going upwards, okay? Now, if I stop and then I do this, notice I'm still going to the right. I'm still going to the right. Now what I'm doing? Well, I'm going downhill. I'm decreasing. It's like a mountain. I'm going uphill and I'm going downhill, right? So the increasing is the region or the interval for which we're going uphill. So if I start here, where do I stop going uphill? I stop going uphill there. And so we would say that this interval from here to here is the region or the interval for which I'm increasing. Decreasing is the opposite. The function is decreasing or going downhill over any interval where the y value decreases or goes down as the x value increases. Again, the x value is always going to increase. We're always moving to the right. So as we move to the right, is this parabola going uphill or downhill? Well, it's going uphill here. And then from here to here, we can see that it's going downhill, right? So therefore, it's decreasing over that interval. So let's go ahead and take a look at a little bit more complicated graph. It's just to kind of make the point, okay? So in our graph, In our graph, we actually have a few different regions here. If I trace this graph from left to right, you should be able to see some hills and some valleys. Well, if I start here and I move to the right, what is this graph doing? Well, this graph is going downhill. It's decreasing. But when I get to this point, what's it do? It starts increasing. It changes its direction. It starts going uphill. And then it stops here, and then it goes downhill again. And then it stops down here, and it goes uphill again. So what is the interval for which this function is increasing or decreasing? Well, what I'm going to do is I'm going to draw vertical lines everywhere it changes direction. So we're going to draw a vertical line there because that's where it starts. We're going to draw a vertical line there because that's where it changes direction. We're going to draw a vertical line here because that's where it changes direction. We're going to draw a vertical line here because that's where it changes direction. And we'll draw another vertical line because that's where it ends. Okay? So in this graph, we would say that we are decreasing from this line to this line. Well, what is that? That's from -6. So we would say this. We would say we are decreasing. Let me pull my paper here. We are decreasing over the interval from -6 less than or equal to x less than or equal to -3. It's an interval, not y values, x values. So from -6 to -3. If we're going to write it in interval form, it would be -6 comma -3. Okay? Well, what's happening now? What's happening at -3? Well, we start going uphill. So we would say that we are increasing from this point to this point, or from this line to this line. So we would say from -3 less than or equal to x less than or equal to -1. We are increasing. Interval notation would be -3 comma -1. Okay, so those are the first two regions. So we're decreasing here from -6 to -3. We're increasing from -3 to -1. Well, what are we doing here now? From -1 all the way to 2, we are decreasing. So we'll add that here. We'll say from -1 all the way to 2, we are decreasing, or from -1 comma 2. Okay? And then from here to here, from 2 to 6, we are increasing. So from 2 to 6, we are increasing, or interval notation 2 to 6. So you can see in the graph there are two pieces for which I'm going downhill and two pieces for which I'm going uphill. Okay? So hopefully that is clear to you. We always answer in terms of x because it says it is an interval. An interval is x values. Okay? All right, so that's my example. You should be writing that down, making sure you have that correct in your notebook. Okay? And I think I add more to it. So I'm going to highlight it's going downhill there, and it's going downhill there. So we would say, and it's going uphill there, and uphill there. Oops, let me go back. So we can see our answers make sense based on those regions. So the decreasing part is the red part, and the increasing part is the blue parts. All right, let's go ahead and take a look at another example here. I want you to go ahead and try and do this on your own. Identify the interval for which this function is increasing and decreasing. Okay? All right, so for this one, we would say that we have two pieces, and those two pieces are defined by the axis of symmetry here. On the right-hand side, we can see that the function is actually going uphill, because remember, we always lead from left to right. And on the right-hand side, we can see that the function is going downhill. Ignore these arrows. These arrows just mean that this keeps going in the same way, in the same fashion. It keeps going up in a sense. But we're not going up on this side because we read from left to right, so we're actually going down. okay? So we would say that this function is decreasing. Well, where is it decreasing? Where is it decreasing? This is an interesting one. Because there's an arrow here, that implies that this goes on forever in that direction. So some of us would be tempted in drawing a line right here at the end. But this graph doesn't end here, it keeps going. So how far this way does it keep going? Well, forever. So we use this symbol, negative infinity. What? Negative infinity. We are going backwards all the way back. Well, that's a long way back. That's infinity. And since we're going on this side of the number line, it's negative. Negative infinity, right? If I start there and I move in the right towards the right, what do we see this graph doing? We see it going downhill. So negative infinity and then x, and then where does it stop going downhill? It stops going downhill at this point. Well, what is that x value? That's 2. Now this is our first example that's going to look a little different other than the infinity. We're going to put less than or equal to there because it stops going downhill at 2. We can't put an equal sign on this side. That should be an inequality. That looks more like a C. It should be less than. We don't want to put an equal sign here because infinity actually isn't a number. It's just an idea. So we can't say it's equal to infinity because infinity isn't really a thing. It's just an idea of going on forever. So we never put an equal sign on infinity. All right, so that's decreasing. So in interval notation, we'd put negative infinity, comma 2. This would be a bracket because it's got an equal sign. When you don't have an equal sign like we do here for the negative infinity, we put a parenthesis. So that is interval notation there. All right, for increasing, where do we start going uphill? Well, we start going uphill at the vertex at x equals 2. And then where do we stop going uphill? Well, this thing keeps going on and on and on, upwards forever. So we use infinity again. This time it's positive infinity because we're in the right-hand side of 0 here, okay? We're going to put less than or equal to on this side because it starts going up at 2. We're just going to put less than infinity here because it's just an idea, it's not a number. And then in interval form, be 2 comma infinity. We're going to put brackets here and parentheses there for the same reason as I said before. All right, let's go ahead and take a look at the next problem. I want you to go ahead and identify all the key features and answer the questions that are given here. So go ahead and pause the video, answer the questions, and push play to go over your answers. So find the vertex axis of symmetry, the maximum or the minimum, the x-intercepts, y-intercepts, the interval of increase, and the interval of decrease. All right, for this practice problem here, we're going to kind of go a little bit fast through this. The vertex is going to be this point here. So the vertex in this case is -5, 0. The axis of symmetry is x equals -5. Let me go ahead and draw that so we can see it. X equals -5 is right there. Okay, so that's our axis of symmetry. Now the question is, do we have a maximum or a minimum? Well, because this parabola opens downwards, we have a maximum, and that maximum is, remember, the y value, y equals 0. Remember, the axis of symmetry and the max or min are both part of the vertex. So you don't even really have to look at the graph. If I give you the vertex is -5, 0, then the axis of symmetry is x equals -5, and the max or the min is y equals 0. All right, in this case, the x-intercepts, well, there is actually only one x-intercept, and it's the vertex. So we would say the x-intercept is -5, 0. The y-intercept is this point right here. That point is 0, -4. And so those things should have been pretty easy. Now we ask ourselves, what's the interval of increase? Well, where is this graph going uphill? The graph is going uphill from starting from the left and moving to the right. It's going uphill, up, 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 until we get to the maximum. And then it goes downhill. So where does it start going uphill? Well, it starts going uphill at -infinity, and it stops going uphill at -5. In interval form, oops, in interval form, let me pull up my graph paper here. It should be increasing from negative infinity with a parenthesis, comma, -5 with a bracket. Okay, so for decreasing, it's the other side of the axis of symmetry. So we are going downhill from this point all the way on to forever. So that would be from -5 to infinity. Okay, now we don't always say infinity. If this graph were to stop right here, for example, then we would say it stops at 0, or it would stop at 1, or it would stop at 2. But we have this graph go on forever. Now, you might have said, well, it stops at something like -10 because there's no arrows. And I guess I can't ding you for that. I was just assuming that there's arrows here. Well, it stops over here at like 2.1. Okay, if you put 2.1 instead of infinity, that's fine for this case. But if there's arrows there, you should be putting the infinities. All right, so the interval of decrease in inequality form is -5 less than or equal to x less than infinity. For the domain of this guy, if we are going to look at where this parabola starts and stops, we would have to draw a vertical line over here somewhere. Well, if this has arrows, and I'm going to go ahead and put arrows here so that we can see it. If this has arrows, that means it goes on forever. So what is the domain in this case? The domain in this case is, well, where does it start? Well, it starts way back at -infinity. And where does it end in the x direction? It ends way out in infinity. So we'd say that domain is from -infinity to infinity, or -infinity less than x less than infinity. Okay. For the range, we would draw, I'm going to go ahead and draw dotted lines here so that we can see it a little bit. For the range, we would say, well, what's the lowest point? So that's a line that's representing my lowest point, but we know that this parabola is going to go past that point, whatever I drew. I'm just putting it there. But what's the highest point? The highest point is the vertex in this case. So we would say the range is the lowest point. Well, what's the lowest that this parabola goes? This parabola goes down to -infinity in the y direction, and it goes all the way up to this line. Well, this line is y equals 0, not -5, because that's counting left to right. How high does it go? It goes 0. So we're looking at the y-axis here from -infinity. So maybe I should write that in here. We'll say that this line, represents -infinity. Again, it's not a number, it's just an idea. So we'd say from -infinity all the way up to 0. Okay, the parabola actually does touch y equals 0, but it doesn't touch -infinity because infinity is not a number. All right, that wraps up this lesson. Hopefully you have a better grasp of the key features of a parabola, the parts of a parabola, and maybe a little bit better feel for domain and range. We've talked about that for 2 days now. Go ahead and do the assignment that's associated with this lesson, and make sure you ask any questions the next time we meet, and I'll see you again next time.